Hello, I'm here to demonstrate about the experiment number 6. In experiment number 6, the program deals with the assembler, that is the single pass assembler for the SIC. In this, what I'm going to do, what is a single pass assembler? Okay, a single pass assembler, it has only one pass, and in this, it will take the source program as input and produce an object code as an equivalent machine language, which is an object code as an output. So the assembly language program then will pass to the assembler the linker, and then the executable code will be generated. There are a few advantages for the single pass assembler. That is, it it is in a compact form. Instead of providing 100 lines of code, it'll reduce the size of your code, and then it'll involve more number of system software, that is the assembler, linker, etc. And it'll the execution time in a single pass assembler is comparatively less than the normal program. Okay, so coming to the algorithm, what are we going to do? We'll first read the input file. First, if it reads the start statement, then what it'll do is it'll initialize the location counter to the operand value, that is the starting address. So otherwise, if there is no value in the operand field, then the location counter is set to 0. Now it'll write the input line to the intermediate file. It'll do this till it encounters an end symbol in the program. So first, there are uh, three data structures used in this: symbol table, operation code table, and then the location counter. So here in the symbol table, first, symbol table is a table in which it consists of the symbols present in the present in your uh, code. For example, I will show you in the program. Then in the operand table, the op codes are present, operation codes are present. So if it encounters normally, when you have to increment the location counter, it will be incremented by 3. But if it encounters a word, then it is also incremented by 3. But if it encounters a byte, it is incremented by 1. Then if it encounters a reserved word, then the equivalent number into 3. So equivalent value, operand value is multiplied into 3, and then the address is generated. So if it is a reserved byte, then it's incremented normally, and so on and so forth for the various things. So now when you reach the last of the program, like this, the end record, then if you subtract the end minus the starting address, the length of the program is obtained. So see here, this copy and all these are the symbols, the symbols which are present in the symbol table. Okay, so now I'll go to the program. Here, what I will here the same algorithm is, the algorithm is same. Now what I'm doing is, I'm initializing an operand table, that is hash table, ready to op table. Okay, now here I'm initializing the hash table again. So that is, the size of the hash table is 30. Then with the help of a buffered reader and buffered writer, I'm going to read and write into the files. So then later I'm initializing the location counter to 0 and the start variable to 0. If my line starts with the start, then I have to start splitting the code, and then I have to store it in an array called C. So the initial starting of the C will be stored in a variable called title. Now what I'll do is, if my length equal to 3, then I'm going to parse it into C of 2 comma 60. So start variable will be initialized to the location counter. Next, else if this is not the case, then I'm going to initialize the start value to 0 and the location counter equal to start. So I'm going to WR is buffer write, that is write buffer. So with the help of that, I'm going to write it. If else it contains end, then I have to update the symbol table with all the symbols. Then if it is line contains end, then I will convert it into a hexadecimal string. So I will I will combine everything, and then I'll write it int length equal to lc minus start. So here what I am doing is the length of the program, I'm going to, the location counter will contain the ending part of the address. So least count, I mean location counter minus starting address will give you the length of the program. Then I will close my close and BR close and WR close, buffered read and buffered, I mean buffered reader and buffered writer I will close. Then now again I'm opening it. So I'm going to do, I'm going to write the object code for this. My output mainly will be the object code. So for the writing the object code, so first the header record. So for the header record, H will be the symbol and quoted with an XOR symbol. Then the title will be the name of the program. Then again, this XOR symbol to 6 integer. I meant 6 will convert the exact. I mean the that value to a 6-digit value, 6-digit binary, not binary, hexadecimal value. So integer dot 2 hex strings of start. Then again I will concatenate it with the XOR symbol. Again 2 6. Then the length of the program. So else if line contains end, system.out.println end record, again the XOR symbol, then 2 6 integer 2 hex of start. Then else if it's not that the case, if it is not the case, LC, that is location counter of pass to line comma operation table symbol table least count and start. So br1 dot close. So now I'm using a for loop in order to find the word length. Till the word length is going on, it will be counting it. So word equal to 0 plus word, the return word. Then now the least, now I will tell you. Now if it is encountering, once again, I'll just show you. Okay. See, here in my program, now copy is the name of the program. So that will be stored in the symbol table. Now is the start address. When it encounters the start, 4000 will be the copy. Then XOR table 4000, 4000 will be starting address and then the length. Then LDA, alpha, SDA, beta. This all will be stored. The opcodes will be generated and will be stored now for 1000, 4003, 4006, 4009, like that. Now it encounters a reserved word. So reserved word 1 into 3. So it will be incremented by 3. This reserved word is also 1 into 3. This is also reserved word. So 1 into 3. So this is the end record. Now in my operation table, now STA 23 LDA, that is the opcodes of the STA, LDA and STX. So next one will be, this is the intermediate code which is generated. So you can see this, and now this is the output which is generated. The the object code is generated. Header copy 04000 and the length of the record, the text record, the 6 hexadecimal values and that length, and like that it will be generated how many ever text records are there, and then the end record will be produced. Okay, so this is these all are done using the operation, I mean the read buffer and the write buffer. That's all for this video, and thanks for watching.